Hello. So this is the second video on homework 5, and in this video we are going to study binary dependent variable model. Okay, the second question of homework is about binary dependent model. Let me explain the data. It's a pretty interesting data. So there was a survey in April 2008 and April 2009. So and at that time there was a financial crisis, so a lot of people lost their jobs, and so our data include more than 5,000 workers who were employed in April 2008, right? And they were resurveyed. They are surveyed again in 2009, and then we can tell who lost jobs and who not, right? So especially we are interested in, we would like to explain who lost their jobs using the variations in age and female, right? Using basic demographic variables, we'd like to see who are more likely to lose a job during the financial crisis, okay? So anyhow, in here, the dependent variable is whether you remain employed in 2009, or you lost, or it could be voluntarily you are not employed in 2009. So the dependent variable is employed. So let me show you the data. This is the data. Actually there are more variables like age, race, earning, weekly earnings, and employment. This is what we are going to use as a dependent variable. A lot of variables, and at the last column we have female variable. Okay, so, and as you see, employed variable has only 0 and 1, right? There are only 0 and 1, two possible values. So we can simplify our setup like this. Why? The dependent variable is 1 if person I is employed in 2009, and 0 otherwise, okay? And x1 is literally age, and x2 is female indicator, right? 1 if woman, 0 if man. And in this analysis, there are two binary variables, y and x2, but actually binary structure in x2 does not matter at all. It does not cause any problem. So it does not matter whether it is binary or continuous, whatever. Our main focus is on y, the structure on y. Okay, so, and then if you make a scatter plot, it's pretty much useless, right? So we observe people's age. So the horizontal axis is age, and the y-axis is 0 or 1, simply employed or not. But also in terms of age, they are the same. At 18 years old, there should be a lot of people at this point. It's not just one point. There must be, I don't know, at least several, say 100 observations here and here. So scatter plot does not help at all, right? This is why we have to think more carefully what is going on in this regression model. And we learned 3 different types of regressions, or basically 2 types, and the second type includes some variations. The first one is just use a linear regression as usual. That is called linear probability model, because what we are calculating is not 0 or 1, but it's probability of 1, right? So what we predict is not expected value, but the probability of the person being employed, right? So given your age and whether whether you are a woman, you can predict you assume the probability is linear, right? And I have explained this is limited. This is simple, which is good, but this is limited because linear model will go beyond 0 and 1. So if you are too young or too old, then the predicted probability can be greater than 100%, or can be a negative number, which is not appropriate in here. So we are going to ignore, we are going to change the model to nonlinear model, right? So in the probability model, we are going to predict the probability using the combination of nonlinear function of a linear function. So linear part is in here, but on top of that, we impose some nonlinearity so that the predicted probability is always between 0 and 1. And depending on which function you choose here, if you choose the standard normal CDF, we call that model as the probability model. But if you choose the logistic function, then we call that logit model, right? Both are commonly used, but in conclusion, they are pretty much the same. So there is not a big difference between probit and logit, especially in this simple case, right? And this function is called the link function, right? So we generalize the linear regression model to include something nonlinear, right? Because we have very special data structure. Okay, how can we implement then? You know how to do the linear probability model. It is just another regression. And then how do we implement probit or logit model? It goes like this. You do not need any additional package. So linear probability model goes like this, the same. But the probit model uses GLM, which means generalized linear model. So this is a generalized linear model, and it includes two more, actually one additional option. You have to specify what you are doing in this generalized model. And logit model is pretty much the same. It's typo. So typo because I copied and pasted from the earlier part. So the only difference is you have to specify probit model here and logit model here. Depending on which option you use, you are going to get different results. Okay, and as you see, this generalized linear model command allows a lot of different types of linear model, different types of generalized models. So you have to specify what you are doing, and what we are doing is a binary model, and it's and here it is classified as a binomial model. Binomial model is similar to binary, between 0 and 1, right? So the family of generalized linear model we are considering is binomial. And among many binomial models, we use link function specified by the probit model. So our choice of link function is probit, and our choice of link function is logit, right? So as you see, within the family of binomial models, they differ in terms of the link function. Which link function you use will make the differences. So you have to specify them, and then you will get the results. Use summary, and rig2 or rig3. Then you are going to get the regression table similar to the linear regression. So you will be able to compare the linear probability model and the probit or logit probability model. But I'm telling you here, and it will be asked in the homework question, beta 1 estimated from the linear model and the probit model and the logit model are different. They are different because there is an additional step, f. The role of f is transform those value into 0 and 1. So depending on this function, the scale of the beta could be different. So they are not comparable one-to-one because of different link function, right? So link functions are different. So it is natural to have different betas. So then how can we compare them? The idea is marginal effects, right? So, and here comes something interesting. Like as I said several times, I'm pretty much new to R, so I have to run these kind of detailed commands by googling. So I I checked how to do it last week. At the time, the Google search result was margins package. So I tried it today, but oh, it says it's discontinued. It's not available anymore in this version. So I had to restudy, I have to study alternative way to do this, right? So in case if you search for marginal effect in probing model in R, you are going to see this package, margins package. Many YouTube videos and many documents is based on this package, but I don't know why, but for some reason it is discontinued, so it's not available anymore. According to my close R expert, it'll be able to I can download this package from somewhere, but I don't know how to do that. So I learned an alternative way using alternative package MFX. So package, install and use package. And the problem is, so in margins package, you do not need to recalculate the regression probability logic model. But now with this package, you have to re-estimate the models, right? Like a regression model. So it's like simple, like this another kind of regression model, but your command is now probit mfx, right? So then, using this command in the result, only the marginal effects are saved as if they are coefficients. Okay. Here comes another difficulty I encountered. Another problem. So after saving the results, regression results to this object, of course I type summary of that object to see the results table, but it did not work. That was another I could not understand why. After a long research, I found that the structure of the results is different, right? Let me show you. So here, let me turn off my face. Up. So I will turn off. So now you can see what I'm doing. I've been doing a lot of things. So for example, logit, when you estimate logit model, this is what you get, like this. And if you use fixed effects model that I tried earlier, like this. But when you do logit mfx, oh, why is it different? So it is not directly under the logit m itself. You have to it is under this category, fit category. So it is different. It's data. Excuse me. Excuse me. Okay, let's open this. If you open this and compare that to fixed effects model, it's not available. Sorry about that. What to compare? Say probing model. In the probing model estimator, you directly have coefficients and residuals and fitted values, and standard errors should be somewhere later. But in logit mfx result, you cannot find coefficients. They are under here, right? Same structure is under fit folder under logit m result. So that means you cannot just summarize the results directly. You have to go to fit folder under the result. So not summary directly, but summary of that result dollar fit. So you have to include this part to have the result. Okay, and finally, so it was a long search, a waste of time, but fortunately I found a really cool package. So Stargazer. Stargazer is a package that helps you make like a regression table. It will make a regression table really like clean and nice and easily. So of course, download, install, and load Stargazer package, and you are going to use this command, Stargazer and results. Like if you have done 3 regressions and just list 3 regression results, like here, and in the end, specify the type as text. If you do not include it, like then the default type is like LaTeX format, which is more scientific, like typeset, and so you just copy this. And of course, if you like depending on what you use, you may not need this part. So the reason why I include $fit is because of this package. MFX package has very special output structure, so that's why I had to list it. So as a result, my code for the binary model would be like this, right? So load packages and like load data and linear probability model. And then I first tried nonlinear models, generalized linear model command. And then I calculate marginal effect after installing package MFX and save the results to say probit M, logit M, right? And then I will make regression table based on this, which is Stargazer, which is cool. To show you how it looks, let me show you the result. If you run this line, Stargazer, then this is what you get, right? So this table is what you get, which is really cool, right? Exactly, this is what I wanted. Now you can compare 3 different results side by side, and you can automatically you can see the standard errors. Automatically stars are decorated, and that will you can use this for other results, not only for probit or logit. Any like panel data and linear regression, all the results can be represented in into this table using Stargazer command package. Okay, so this is the end of the last homework. I hope it helps, and see you next week.